Right. So today is the second of the set of lectures about Spark, and today I'm going to tell you about the way in which you can interact with data that you've got in Spark in an SQL-like way. So we've already met this idea when we talked about Hive, and it's kind of the same approach. It's this idea that this isn't a database all of a sudden. It's still data and files and all of those things that stuff stored on HDFS. But behind the scenes, it gets organized in such a way that allows you to phrase your queries to the data or phrase the processing that you want to do to the data in an SQL-like way. All right. So this isn't another new database or indeed just a relational database. It's just a way of taking an interaction that you already know about, SQL, and allowing you to apply it to the data that you've got in Spark. So you're probably not that surprised to learn that, now that we know how Hive does it, that Spark actually can read data straight from Hive. So if you set yourself up a Hive structure in your folders already, then you can use Spark to talk to it. The main thing about Spark SQL to remember that really makes it not a database is, remember we talked about Spark, the fact that the reason it runs so fast is that it runs in memory. And so the SQL queries that we're going to be using in Spark, or that we're talking about today, all operate in memory. So the basic message, the basic process is you've got some data, you take it into one of the Spark data structures, and I'm going to talk about two of those today, one we already know about and a new one. And then you simply use SQL-like language to talk to that data that is in memory. Okay? So it's a nice way of interacting with the data that you've already got distributed across your cluster in Spark's distributed memory structures. So that's actually what you're interacting with when you use Spark SQL. So I said I'd tell you about a new data structure. It's probably not new to you. I expect most of you have come across the idea of a data frame. Anybody who did the Python course would have looked at pandas, the data frames in Python. Data frames are the central data structure in R as well. And just a reminder, in case you either didn't do that course or you've forgotten, a data frame, the easiest way to think about it is like an Excel spreadsheet, okay, but it's held in memory. So you haven't got that user interface that Excel gives you, but basically you've got columns and rows, and you can do stuff to them, right? You add up this column, move these columns about, so they're indexed so that you know which column or which row you happen to be addressing at the moment. But it's a data structure. So you can think of it like a spreadsheet, or you can think of it as a single table in a relational database. Right? It's that kind of structure, but it's held in memory. And so you can access it by, you can give the columns names, for example. So you can say this column is the column for age, and I want to calculate the average age, for example. So you can kind of interact with data in a structure, but by giving them the columns names. Usually the rows are indexed by something like a number or a date or a sequence or some such. So the data frames that Spark offers are exactly that concept, a giant table, but it's stored in memory, it's distributed across the cluster, and now, for example, when you say give me the average age, the numbers that it's taking that average of might be distributed across a number of machines, okay, because it's spread that data structure. And it's an additional level of abstraction. So when we talked about these resilient data structures in the last Spark lecture, and I said that you've got maybe an array, but it's a very long array and it's spread across several machines. If you wanted to add up all of the values in that array, then you could do some kind of array sum. and you wouldn't need to know which machine that was on. So that's one level of abstraction. You don't have to say, right, go to the first machine, do this, go to the second machine, add them up and so on. You just say to Spark, I've got this thing in the cluster, in memory, add them all up. So Spark SQL is an additional level of abstraction. Now we've got the SQL-like language to interact with it. So we set up a data frame, it stores it for us across the cluster, and now we can just say things like, select average of age from whatever the data frame is called. But I'll show you some examples of that in a few slides' time. And so it's these data frames that live behind the Spark SQL API. So, all right, let's have a look at a little bit of code and see how it all works. So this is just the first thing you have to do. We have to import the SQL context. So that's we've got the PySpark library. We import the SQL context, and then we set one up. So this is just the kind of stuff we have to right at the start. Remember, FC is the Spark context, which is already instantiated for you. So basically, we're just getting this context in which we're going to run the rest of the commands. And so for the next set of slides, I'm going to talk about how you get data into one of these data frames, because basically the process is get your data from somewhere, put it in one of these distributed data frames so that it's now in memory across the cluster, and then interact with it using SQL, that last bit being a reasonably straightforward bit. And so there are three places that I'm going to talk about that your data might be at the moment, and you want to be able to get it from that thing into a data frame so that you can start interacting with it. So the first one might be an existing RDD, so these are these resilient distributed data sets that I talked about last time, and we saw how you might set one of those up. Or just a data source on file or something like that, something you've already got stored in a file system, or a Hive table that you've already defined using Hive. So we'll go through the three of those in turn. And so the first one couldn't be simpler, really. So we've got this SQL context already that we got on the previous, yeah.
When data is updated, then is it dynamically updated in the memory, or it need to be updated? For example, data is updated at original place.
No, so it's read from these things, but there's not. And actually, you remember in Hive there wasn't a concept of updating. So this is about reading, not about writing.
No, but once it is read, then it is dynamically updated if the original data is added or something like that.
Oh no. You read, it's like opening the file. Well, no, it's like opening the file and reading it into memory. If that file then changes, and you don't know about it, then no. So this is a reasonably short-lived thing, right? The process is, open the file, read the file, process what you've got, you're done.
You say the data source of file, can it be a file? I mean, HDFS file.
Yes, that is what it will be. Yes, yeah. Well, yes, it could be a local one as well that you send it, but either of those. Okay, so the first one we remember from last time that we create some kind of RDD. So imagine I've already done that, and I've got this variable that I call RDD. So I've created one, and I want to turn that into a data frame. Then everything's run from this SQL context. So I just do create data frame and send it in, and that's it. I've now got a data frame, and this will return it. That's how I get hold of it, and then I can start to use it in a way I'll show you in a few slides. So that RDD in its own right, maybe that's already a matrix or something, so it's got columns and rows. But actually, generally speaking, in order to write SQL properly, and for the whole point of this to work, we want the columns to have names, right? We want to be able to do select age from whatever. So what we want to do is impose on top of our data some kind of a schema, right? And the schema defines things like the name of the column, the data type of the column, and so on. So instead of just sending in an RDD, we could send in an RDD and a schema, which we'll define in a minute. And that says, take this data structure, turn it into a data frame with the following schema. All right. And then the schema can be either a struct type, which I'll talk about in a minute, or just simply a list of column names. So the simplest version is you're just naming the columns in the RDD. A slightly more complex version is that we're going to use one of these structure types to define something else about it. So let's have a look at that next. So we need to import this types library in order for this to work. And the basic idea of this is apparent really from this bit here. Each of these struct field objects defines a single field in a structure. All right? And we just define them on the fly as we go. So what I'm saying here is I want to set up an array. I've called it fields. Here's my array bounds. And this example's got, we're assuming 2 columns, right? The first one is called age, the second one is called gender. You can probably guess the first one is an integer, the second one is a string. And that's how we define it. And then we send that array into this struct type function here, and it returns us a schema. And that's the schema that we send in. So we can now do create data frame, send in the RDD, send in the schema that we've just created, and that will produce us here a data frame which contains the data that it's taken from here and is defined by the schema that we've given. Okay, so we now have something in a data frame that has named columns. If it doesn't line up, you get an error, obviously, and also typed columns. So that allows SQL type queries that require a type. Yeah.
In our file, there's the first word should have the column name, or in this case, it's not necessary.
No. So the column names are defined in there.
Okay, so if he has a column name, in this case, it would be an error because age is not a number.
Yes. Okay. Yes. And quite often in HDFS and Hadoop related stuff, having the column headings in the first row is problematic, because if you think about MapReduce, right, if you split the file across, one of the versions will have the headers and the rest of them won't. And then so you can't rely on your mapper, and the mapper doesn't even know which row it's on anyway, right? So generally speaking, column headers isn't the way to go.
So if there is a data type mismatch, even then it accepts this command. For example, I do have this string data type rather than int, and I define it as int data type.
Yes, you'll get, certainly if it's a string and you try and treat it as an integer, you're going to get an error. If it's an integer and you try and treat it as a string, because it's just characters in a file, that's fine, right? It'll just treat them as characters and treat them as strings. But yeah, the other way around, you're going to get an error. Yeah.
Basically, you have the fields, you have in order, and the columns are the data frame.
Yes, in the same order. Yeah. Yes. So yes, this does assume that you have an intimate knowledge of exactly what's in here and the order in which it comes. There's no other way of lining them up.
So all data types are supported in this, for example, Boolean data type or any other data type?
The SQL ones are supported. Yeah. Right, okay, so then, finally, we can do something that looks a bit SQL-like. We're not quite there with this, but I think you can at least, you could convert this quite straightforwardly yourself into SQL, right? You can see what it's doing. We're selecting the column that's called age, and then my dot filter here is like a where clause, really. Dot filter and then df. So when you access a column in a data frame, then you're using these square brackets to indicate which column, and then inside the index, in this case the index is the name, so it's a string. So we're selecting age where age is greater than 50. But you'll see a different way of doing that coming up just now. Alright, so we've taken our RDD, we've converted it to a data frame, we've defined a schema, and I showed you an example there of using the Python API. So that didn't quite look like SQL, but you kind of recognized what it was doing. So that was the example of the first one, the data frame API. Or if you prefer, you can send SQL as you recognize it straight in. So there's one extra thing that you have to do, one extra step that you have to take. Here it is. If we want to send in SQL, we have to create a table from the data frame. So it's one extra step. Basically, it's not creating a new memory structure. It's just saying that this data frame, we want to turn it into something that the SQL API can talk to. So, and the main thing about that is we need to give it a name, right? So that we've got a name of a table to talk about in our SQL statement, because that was the one bit that was missing previously. So we registered the table from our data frame, and then finally here, you can see we're not mentioning the data frame anymore, because we've already given it a name here. So that obviously refers to that. And now we're just using straightforward SQL. So we've gone through a few steps, but we now have in memory our giant data structure, and we're able to talk to it via straightforward SQL that we all hopefully know what to do with. So yeah, once we're at this stage, the select, obviously not the update part of SQL, is all available to you. So again, apologies for those of you at the back, but you can look at these on the slides if you can't see it from here. It's just an example of me running it through in, and actually this one, the loans file, I think this is the file that you've got if you're doing BD6. So in this one, it's a bit tedious, I can't even see it to be honest, I'm standing next to it. In the first few lines, I'm opening the file and pulling out the age, because I know that column 3 has the age. So I'm doing this in the way that I showed you last time with a lambda function in the first couple of 3 lines. And then after that, I'm doing the same thing again, but this time using SQL. So I'm creating a data frame, creating a temp table, and then here I'm just sending in an SQL statement. So this time, select gender and the average of age from people grouped by gender. So actually, now you can start to see that having started with a file that was just columns in this case, just 2 or 3 lines of code, I've gone right to the point where I can do proper group by aggregation. And because this is all happening on a data structure, it's really nice and fast as well. It's not like running the MapReduce jobs that we were doing at the start of this course. I could run many of these one after the other and immediately get the answer back. So you can see what that's quite attractive. And if you can see it at all, here's the result of that coming back as a data structure. So that's what gets returned from these queries. So this is an array. You can see the start of the square bracket. So I've done an SQL query, so you probably remember the result of doing an SQL query is going to be 1 or more, so 0 or more rows, where each column is the things that you asked for. So I should be expecting 1 row for every person in the file, or the data structure, and 2 columns, 1 for gender and 1 for the average. Sorry, I'll start again because I've done the group by. I should have 2 columns, 1 for gender and 1 for the average age, and the number of rows should be the number of different values it found for gender, right? Because that's what I've grouped by. And this file, because there are some errors in it, has 1 for female, 1 for 0, 1 for 1. Obviously somebody's coded those incorrectly and so on. So I've got a few rows back, and each row is an element in the array. So if I want to process that, I just have to step through it.
The couple is an element, or
Sorry?
the gender and average is an element of the array?
Yes, yeah. The 2 things that were selected, in that case it was the gender and the average of the age. And so I got that back into a variable that I called avAge, and here I'm just iterating through it and printing it in a slightly more accessible fashion, right? So just to show that that's what it is, it's a list that you iterate through. And so you can see all the different values that the group by produced and their associated average ages. And if I want to do it in the API instead, then I've got this thing at the top where I say .print schema for the schema that I defined there, and it tells me what the schema for that particular data frame is, if I've forgotten. And now this time I'm using the API method rather than sending in SQL. So I'm saying group by gender and count, and that's all you need to ask to find out how many there are. And so here you can very quickly see that the correct codings are probably F and M because the counts for those are very high, and these are obviously all data entry errors or inconsistencies with the coding. So those are the two ways in which I might interact with the data. Right, okay, so a few slides ago I said that there were 3 different methods for getting data into one of these data frames. I showed you how to do it directly from an RDD, and then we kind of ran through to the end of how to actually get it into a table and write a query. So we'll take a couple of steps back now and look at the other 2 data source options, getting it from a file and getting it from Hive. So first of all, looking at getting it from a file. So we've got this SQL context.read. This is the main method we're going to be using to do that. And it has different versions there are different readers for different file formats. So here, for example, I'm reading a JSON file and I'm giving it a path and the name of the file. So that's quite straightforward, and that's read that file directly into the data frame. And because it's a JSON file, we don't need to provide a schema, at least for the names, because it will automatically work out what the schema should be by finding the keys, which are basically the column names, right, from the JSON, and their associated values, which are the data. So JSON has its, while it's not a tabular schema, it has all of the possible column names in it. There's also this file format called Parquet, which we haven't looked at before, and it's a column format file format, but it comes already loaded with a bunch of stuff like built-in compression, built-in schema definitions, and so on. So if you find out a bit more about Parquet, and you're doing lots of tabular file stores that you're going to access from Spark, then Parquet is quite a good format for doing that. So I'll just tell you a little bit about that. It's another Apache project, and you can use Parquet files across all of the Hadoop ecosystem. So you can store them in HDFS, you can run MapReduce on them from Java in the way that we learned before, you can read them into data frames in Spark and so on. So if your project has tabular data and you were thinking of just storing it CSV or something like that, then probably Parquet is a better option for that. It just gives you those extra things. As I mentioned, good compression and encoding works well on HDFS, and actually you can have nested structures. And sometimes, quite importantly, if you've got large quantities of data, it's got an efficient way of handling sparsely populated data. So imagine you have, I don't know, 10,000 variables, really wide table, and millions of rows of it. But each entry perhaps only has 4 or 5 of those columns actually filled in, right? So it's really sparse. Then you're going to use up massive amounts of memory if for every missing one there's a column or a delimiter of some sort. So there comes a point when your data is sufficiently sparse where it's more efficient to store the coordinates of where the data is and the data at that coordinate, right? So you might say, for row 1, I've got data at locations 10, 100, and 350, and those numbers are 1, 5, and 10 or some such. Right? So that's a lot better than having 10,000 empty columns with their delimiters associated with them. So Parquet can handle that kind of thing. And it's the default file type for Spark. So if you end up running a project where you're going to be using Spark quite heavily, then again, Parquet is probably the choice. And if you want to learn more about it, there's all the Apache projects, Apache project name, apache.org, and there's some quality of documentation there about it. So, if you've got a file that is in some other format, it's very easy to convert it to Parquet. You get it into your data frame in however you've done it, and then it's just that, .write, .save, and it's got this bit at the end here, format equals Parquet, so that tells it what format to write. Or you can use this other method that I used the .json version of here, write.parquet, and then you just give it a name. And that'll write it all out as a Parquet file with all of the qualities that you want. And here you can see an example of me doing a selection and writing the results of the selection directly to a Parquet file. So from my data frame that I've already set up, I'm selecting 2 of the columns, and then with the results of that, .write as a Parquet file, the name of the file, and probably the path in reality as well. So quite a nice, quick way of interacting with the data and creating this quite rich file store. And then you can see here, once you've chosen to use this file format, then things get very simple. We read the file, we do this register temp table again, and then we go straight to writing our SQL queries. So just 3 lines from the thing being somewhere on disk to it being read into memory, set up so that we can call it something. That's the kind of temp name for the file as far as our SQL statements are concerned, and then we can interact with it from SQL. Well, from using it. The
previous one had the register table as well.
Well, the previous examples I'd shown, well, they're the same except where the data's come from. So this data has come from a Parquet file, and the previous one had come, well, originally from an RDD. But actually, by the time you've got to this, by the time they're in the data frame, those 2 paths have converged, and you're doing the same thing to both. Yes. Okay, so that's Parquet files. You can also read JSON. I think I already mentioned that Spark can infer the schema from a JSON data set and load it straight in as a data frame. There's a bit of a restriction on how your JSON file has to be organized. It must be multi-line, and it must have 1 line containing each separate valid JSON object, and then it'll read those in a row at a time and convert them into the data frame. And remember, the data frames can have embedded kind of hierarchy. So you can have a table within a table and so on. So unpacking JSON into a tabular format is not always a very pretty thing, right? Because you might have every single JSON object having different fields, and that's going to create, well, a very sparse table, right? So you kind of need to be a bit careful if you're using JSON and expecting it to fit into a tabular form. But, you know, assuming your JSON is reasonably well structured, then you can do that. So again here, pretty straightforward. We read a JSON file. Now in this case I'm using this print schema function again to find out what the schema that Spark has extracted from my JSON file looks like. And that's probably a good idea before you start interacting with it, particularly if you don't know exactly what was in the JSON file. Yeah.
If only one record has a missing key, still it's is not able to
Missing.
missing in JSON record.
Yeah.
If they want missing one field, only one record between 1 million, still you cannot make it table.
Oh no, you can always make it a table. That's fine. Yeah. It's just it might be quite sparse or quite complicated. But yeah, it'll always be able to do. And then we haven't really looked at R, but the R software, which I'm sure some of you have come across, has Spark R, which is a package that provides a front end to Spark. And I've already mentioned that R uses data frames as its central main data structure. So it's a reasonably straightforward thing. If you know something about R, it's reasonably straightforward to move your data from, or rather to use R on the data that is already distributed in Spark. And there's this Spark R interactive shell that we can use to play around with that if you've done some R. Right, okay, so we've done those, and then finally, if you've already set yourself up a Hive table, like we talked about a couple of lectures ago, then basically you've already defined everything, right? You've got your schema defined, the data's there in its tables, and so all you need to do is get hold of the Hive context, and then from whatever source, well, I failed to define the source in that one. So from whatever file your Hive table has already been set up in, which is what the source is here, then you can type your SQL. And the queries that you're sending in are in Hive QL, which is Hive's version of SQL, which is pretty much the same. Right, okay, so, okay, it's a bit shorter than some of them, that's all right. Yeah, so if you've got data in a tabular or reasonably tabular format, and the types of things that you're expecting to do to it are SQL-like queries, so selecting group by, kind of restricted to the set of functions that SQL has for grouping and comparing and so on, then it can be very convenient to impose this schema on top of it and interact with it in that way. And those of you who have got used to sometimes, I've done this quite often in the past, you've got a big table of data somewhere and a set of things that you want to do with it, and actually you find the easiest way is to just shove it all into an SQL database and query the database, because that's quicker than, especially in something like Java where you'd have to go through every column and add them up and so on. So this is a kind of version of that, really. Saying if you know that the set of things that you're likely to want to do can be easily achieved in SQL, then this is probably quite an easy way to do it. But remember, it is still just creating you a front end that allows you to type SQL that interacts with the data structures in memory. As I said at the start, it's not another database. If you went through all of this and then shut down the machine, you wouldn't suddenly have an SQL-like database. It really is just to interact with memory in a slightly more convenient way. Yeah.
Can you use these to manipulate the data and after through these import the data in SQL databases?
Yes, there's no reason why you couldn't. You'd need, whatever, I suppose, yes, if you're using Python, then there's a Python API that will talk to SQL. So once you've got your, let's say you've done whatever manipulations it is, you've got a data frame in memory, then you could either iterate through the data frame writing using the Python SQL, MySQL, let's say, MySQL API to write it straight to there. Or I suppose the other thing you could do is dump it to a file and use SQL as a bulk loader. Would that be quicker? Probably not, actually. I suspect
No, because
Good idea,
sometimes
yes.
when you do that, the type of data that SQL recognizes is not always correct. So.
Yeah, anything obviously, the embedded aspect of data frames isn't going to play well with an SQL table. But as long as it's flat, then yes, it ought to be able to get into there. Yeah. Okay. So, any questions? Good. All right. I'll see you later then. Thanks.
Always.